Hi everyone, it's Mrs. Summer here to talk about lesson 605, Systems of Equations Elimination Method. In this lesson, students will be able to solve a system of equations using the elimination method. If you recall, a system of equations is a set of equations that you graph on the same graph. The intersection point is the point on the graph where the two equations intersect. This is the solution to the system. Answers must be written as a coordinate pair unless it's a word problem. So what is the elimination method? The elimination method works by adding the two equations together to cancel one of the terms. You solve the new equation and then substitute that answer into one of the original equations to solve for the other variable. So solve the following system using elimination. So there's my equation. Step 1 is check to see if you can already add the equations together to cancel a term. If you can't, you must perform multiplication on one or both of the equations to get one of the terms to cancel out. Step 2 is to add the equations together. So I have this equation and I have this equation and I'm adding it together. I can already cancel, when I add those together, negative y plus positive y is equal to 0. So that's where we're eliminating a term. So I'm left with 5x equals 5. Step 3 is to solve the equation. So 5x is equal to 5, x is equal to 1. Step 4 is to substitute your answer into one of the original equations. So I'm going to take this answer and substitute it into that one or that one. It doesn't matter which one. Then I chose to use the top one. I get 9 times 1 minus y is equal to 3. 9 minus y is equal to 3. Negative y equals negative 6. So positive y must equal positive 6. The last step is to write your answer as a coordinate point. Unless it's a word problem, then answer the question being asked. And then as a coordinate point, my answer is 1, 6. Here's a different example. So step 1 is to check to see if you can add the equations together to cancel a term. If you can't, you must perform multiplication on one or both of the equations to get one of the terms to cancel out. These equations the equations here in our example, cannot be eliminated immediately. You can't add them together to eliminate a term. So I must perform a multiplication to make them eliminate. So it's very, very helpful in all of these elimination ones is to write equation 1. So my equation 1 was this one, EQ1. And my equation 2, EQ2, is my blue equation. The reason being is after I perform multiplication on one of the equations, I'm going to have a new equation. So my equation 2 is that, because I didn't change anything about it. So my new equation 1 after distribution is negative 6x minus 4y is equal to negative 8. Step 2 is add equation 2 and new equation 1 together to cancel a term. When I do that, my 4 y's cancel, and I'm left with negative 4x equals negative 8. Step 3 is to solve that equation. So I have negative 4x equals negative 8, x is equal to 2. Step 4 is to substitute your answer into one of the original equations. So I chose to substitute it back into equation 2. And when I did that, I got 4 plus 4y. So 4y is equal to negative 4. Y is equal to negative 1. And then step 5 is to write your answer as a coordinate point unless it is a word problem. Then answer the question being asked. So as a coordinate point, it's 2, negative 1. So now I want you to try using the elimination method to solve this problem and write your answer as a coordinate point. Here's the work for the you try problem. Make sure your steps match up and your work matches up. Here's a different you try. So solve the following system by elimination. Write your answer as a coordinate point. Hint, you will have to use multiplication on both of the equations. And here's the work for that last you try.